We're now going to move on to the next presentation. This is going to come from Estonia, and it's discussing a fairly similar topic of metadata and images. To present, we have a duo of presenters. This is Mirjam Rääbis from the Estonian National Heritage Board and Tiit Sepp from STUK, a technology company. Please.
Thank you. Hi. I'm trying to make this work. My name is Mirjam. I work in the National Heritage Board. I'm the head of a very small but eager museum team there. We are 4 people, and even us are dreaming of AI solutions. We are responsible of developing the museum field in Estonia. We have been developing a centralized museum system, MuIS, from 2008. All our Estonian listeners already know this, but I'm hoping that there are some that have not heard. But this has been a very big work for us. 13 years of work, almost 4 million museum objects described. I don't know how many hundreds of people doing it, but in this system that is online available and everything is available also in open data, we have 60 museums that are using this in Estonia. So naturally, we have started thinking for already a couple of years that you have all this data, you need to get something more out of it. And also you see the struggles that museums are going through making all this data available. What motivates us to think about AI and data analysis? When, I don't know, 10 years ago even, or 20 years ago, a museum was filled with collection keepers who had been there for 30 years, 40 years. They came there after university, and usually they left, to be in their retirement. They are still the true databases of museum collections in Estonia. But nowadays it doesn't work like that. People come and go, nobody really knows what the collections are filled with, how much they have been described, and so on. So we, as a National Heritage Board, have started to think how to help museums describe objects and make this data available for people who have not lived in these collections. And of course, like I said before, we have almost 4 million objects. It's a lot. It's everything you can imagine that is in the museums. It is a lot of information, a source of wisdom. Like Ott in the morning said also, we have a responsibility to make this history available in different ways. And that's why we want to get as much out of this data as possible. And sometimes it might be a little bit schizophrenic, because you kind of want to make more sense of it, but there are challenges. Of course, we also want to be in the forefront of innovation, like has been said many times here today before, for the same reasons I've described. And we think that AI is the future that we need to be part of now and not later. So a couple of challenges we have been trying to solve for past 2 years using data analysis or AI, machine learning. For example, there was a project that we tried to make sense of ethnographic collections in Estonian museums. to find out if there are any gaps with all the rakes and tankards that we have in the collections, or maybe there are too many, but how are they used nowadays even? And that's also due to the fact that we are trying to build a common storage facility for all Estonian museums. So we are trying to make sense how the Estonian museum collection or a state collection really looks like and what we can do with it in the future. And for the same facility project, we tried to understand how much room do we need to build this common storage facility, because in the MuIS system there are all the measurements, techniques, materials, at least, well, we thought were described. Well, we didn't get much done with this project because there are a lot of gaps in describing the objects. And now, just last month, a project, Sälli, ended. I also want to mention that it's very important to name your projects or AI projects, because when you name it in a way that people remember, then people start talking about it, and there is a lot of interest in our project as well because of that. But Sälli tried to work on assessing the preservation of museum objects to understand when a museum object needs human touch, or what kind of materials are preserving better or worse, and how are they doing. And to make a guide to help us make these decisions, what needs interference. And Tiit later will talk about this project more closely. I'm just making an introduction here. And now we are planning a project called Folli, another great name. And that goes very well together with the previous talk about how we can use image recognition to help describe and automate these museum objects better. We are also motivated here by the time that museum workers spend describing objects. They have not been this only for the past 13 years. They have been doing this from the past 100 years, and doing it now again with the information system. So Folli will be our next project, and I hope that next time we gather here, maybe we can talk about this again. But like said today a lot of times, quantity and quality is a true wicked problem of data and developing AI. So one of the, I think, biggest conflicts is how different people take this assignment. We in the National Heritage Board or in the state, we think that there is all this data and whatever there is so much ways to use this, but a collection keeper that describes every day or inserts this data, they have completely other motivations, and these have been changing over time. So there is a lot of problems with accuracy, validity or completeness of data that we have. And of course, the system that we have been developing has changed. Now we are building a second version of it right now, and it will be live next year. So migration of data from one system to another and making minor changes how we describe objects changes a lot of all this data that we have. All these 3.7 million objects. So it is a wicked problem that I don't have any answers to. but I don't think that we should stop here and just give up, because well, I'm not a data scientist, and in my team there is no people like that. We are just ordinary museum people, but we have dreams and we have goals that we want to achieve. And I think we also owe this to the society, that when we preserve and keep all this data, you need to use this and you need to make it better. So we take baby steps, and we will be building in the future AI solutions, many AI solutions that will work. And I will give the word to Tiit now, who will talk about Sälli.
Hello on my behalf as well. My name is Tiit. I work with computers, and in this talk I present you a bit about the Sälli project we shared with the National Heritage Board. And the main focus is that since turns out we have a lot of heritage actually want to preserve, to keep for the past and for the future. So we have around 3.7 million objects. They only like 2.6% of them are part of any exhibition. So meaning that 97% of all the objects we have gathered from the past are actually hidden in vaults and taken out only from time to time. These objects tend to be from 1,000 different types, and they're made using around 6,000 different techniques and out of 570 different materials. This obviously is a lot of knowledge to gather. This doesn't fit actually into any human's head, but luckily it does fit into computers. And where it currently resides is like these big museums. There's a list of the largest Estonian museums, and all the museums that have this marked in blue were part of this project. So we have this Estonian National Museum, we have all these various museums that took part. And in every museum, there are these really smart museum workers who are looking at this object, taking care of the objects. And every 5 years, they technically would need to take out this object, look whether it is as good as it was before, because obviously we want to keep these objects forever. Because if we lose the objects, we lose part of our past, which is something we really don't want to do. But it takes time to actually evaluate whether this object is in the same condition as it was 5 years ago, 10 years ago, or whether it needs some kind of preservation to make it more the way it was 100 years ago, where it actually might originate. So if actually we start from object 1, and all 70 museum workers will start to tend these objects, it takes around 90 minutes to tend one object. Then it would require 90 years to evaluate all these objects, which is obviously something we don't have every 5 years, because 5 years is a time frame we actually want to evaluate all the objects. So we have to turn to computers to make the work smarter, because we know that since some of these objects have been there for over hundreds of years, we maybe don't need to look at every object. We might just need to look at these objects whose conditions might get worse. And for this, we took a small fraction of all the museum objects that have several evaluations, because it turns out that computers and AI are like babies. They need to test something several times before they actually gain any knowledge at it. So like a baby who puts his finger into a plug, he needs to do it several times before he realizes that this plug contains electricity and electricity is bad. So we actually need several objects that have been evaluated multiple times, because we need to know when the object conditions get any worse. And only 1/4 of the data had this kind of evaluations, and only 1% of these objects had any kind of worsening or bettering of their condition. Worsening is obviously bad, because this is 1% too many, because we want to actually keep everything getting better. And so we have like the objects I have in Estonia, like 4 types of statuses. They can be like from really bad to really good. As we can see from this nice diagram, where every gray dot simulates the status of object, that more objects tend to get better. These are the Screenlines, than they do get worse. So out of every like 10 years, 0.3% of objects do get better, which is really nice. But it's still a bit too few. So we need to actually find only this 1% of objects which do get worse. And this is where this really smart, fascinating AI machine comes into play, where you like plug in all the objects, and it will tell you in time how their condition will change. And we only care about this part where it does get worse. Because if it does magically get better, then that's good. And that's not really a problem. We're really happy if it would do that. And for this, we created a really simple model. Because if you remember, previously we had around 600 techniques, 1.6 thousand different object types, etc. But as I told you previously, computers tend to be like babies. They cannot learn too many features in the same time. Like, they need to like put their fingers into the plug several times before they figure out the plug contains electricity. And they probably need to do it like several more times if the plug color changes from white to gray. And then they make actually the connection that all plugs are kind of bad. So we actually reduced the number of knowledge we take from every object. So we only took some object features, like which material it is, which technique it is. It's recorded usage history, so when it has evaluated, and the object's known statuses across all the evaluations. And then we plug in all these features into a model and ask like obvious question. In 10 years' time, which of these objects would get some kind of condition worsening? And we measure it based on if we get all the, what we mostly want to focus is if we do get all these objects whose conditions get worse. This is computed by this really fancy like statistical metric called recall. It means like basically the fraction of all the objects that got worse, all the objects that we measured, estimated that will get worse, divided by all the objects that got worse. So obviously, if we would say that every object gets worse, the recall would be 100%, and we're good. But then again, we have to move back to this point that there are like 2.5 million objects that have multiple evaluations, and even if 70 persons would evaluate them, we're back to the 70 years, which we don't want to be. So for this, we need to actually have this different metric called precision, which means that all the objects, the fraction of all the objects that did get worse compared to all the objects we say that will get worse. So it is kind of like okay to be a bit pessimistic, but only like 50% of time. So we can say that the glass is like not full, but it needs to be at least half, it can be maximum half empty. No more, no less. So we did just a lot of cool modeling. Everyone has a really cool name. Like we have like naive Bayes, which is named after a British mathematician who wasn't naive at all, but the name kind of stuck. Then we have these decision trees, which are not thinking trees, but they're kind of are branching models. Then we have this X-Key Boost, which is not an American soft drink, but a really cool model. And we tried to measure all the recalls and precisions. So recalls go from left to right, and precision goes to bottom to top. The perfect model would be that the data is only 1 point, and this is on the top right corner, which we never reached. But we reached this conditions that with 50% of precision, we could estimate 92% of objects that got worse, which is not the best result, but it's still something. And if we would start using this kind of system, we actually might save around 70% of human time, which is obviously a lot more valuable than computing time, because humans aren't babies. Humans are smart, and they need to do smart work. Computers are cheaper. They work all the time, unlike humans who want to sometimes get Saturdays off and sleeping in the night, etc. They're free of all these problems. And they only crash from time to time, or when Windows needs an update, which happens from every second week. And so they're kind of cool. And we presented these results in this kind of user interface, where the museum worker can actually see the objects, how risky you think it is. And then he will notice that all the objects that are high-risk objects, they need to be looked prior to the objects that tend to be low-risk objects, obviously, which is kind of reasonable. We integrated all this. The system can be integrated into MuIS. So when MuIS gets developed into a new level, we can integrate our system into this new MuIS. But it does need some kind of improvements, obviously, because it was this prototype project. The user accessibility can be improved, because easier it is for users to actually use the interface, the more time it always saves. Because the more accessible the interface is, the more time we save at looking every object, no matter whether its condition is good or bad. And this also is related to the second point of general functionality, how to sort, filter out all kind of these processes that the museum workers are doing from day to day. The model should be better, because we still missed about 8% of objects. This is something we cannot be ever happy about, because it means that if we would rely on this kind of system, 8% of history would get into this process of fading from our memory, which is really, really bad. There are also some kind of alternative approaches we could use, like using word classifications about descriptions of what is a problem with the object. We couldn't use it immediately because humans are creative. They don't write always like machines would love them to write, like object corner, some kind of fault, hole into blah, blah, blah. Humans tend to write with normal human sentences, which are really fine to read for humans. But these baby computers we use, they kind of don't like them. Obviously, you could improve it with smart warehousing, so that museum worker wouldn't need to actually just go fetch the object, but the museum would fetch the object for the worker. Because again, walking in the museum is good for your 10,000 step daily limit, but it's not really effective in using your brain power to do the actual smart work you should do. But it might be a start. So there was a saying that life gives you lemons, which kind of is actually wrong, because lemons were kind of developed from citrus fruit plants somewhere around year 700, and humans spent millennia of years to actually plant lemons all around the globe so that life could give us lemons. But maybe this might be the start of our small lemon, and if at one day you look at the blue sky, you could see your little yellow lemon tree. Thank you. Questions?
Thanks very much for this. I think you need to clarify a little bit to our viewers here. What did your algorithm use? Was it metadata? Was it images? Was it a combination of them?
So basically the categorical features we had for the objects. So which material it was made of, which technique it was made of. Also, all the evaluation history, which is the most important part. Because we need to know which kind of objects and when do you get worse. So, and that was like highest limitations because many objects we actually don't have several evaluations. And so it's really hard to predict whether this object does get worse or it will magically improve.
But the fact that they did get worse over time, that was recorded as a text, or was there also image evidence of these damages or, I don't know, defaults?
As a text.
As a text?
Right now, yes,
Okay.
yes. But that's analysis and prototype, so Sälli that's the first version of Sälli.
Okay.
Yeah.
We have a question here that asks, what about data about the storage facilities where this object stayed in that during that time when its condition got worse? I guess is the correct way of putting it. Aren't those what influence objects most? And what also about when the object was exhibited somewhere? Was there an impact of it being on an exhibition in between those two measurement points?
Different things can affect objects. Of course, the usage of it, like you said, getting out of the storage room, being in the expositions or mostly expositions. That's the most common usage of museum objects. But also it can rely on techniques and materials, like how old is the object and how it's been used before it came to the museum. And of course, our storage facilities in Estonia, like everywhere else in the world, need improvements a lot. So even staying in the storage room can make damage.
Did you also explore why did some objects get better over time? Was it because they weren't exhibited or
mostly they
were?
get better when they are conservated, yes.
So this magical getting better event is most likely happening only then when because the evaluation is like a human process. And one human can say that this sword is like really nice, everything is okay, but the other can be a little bit more strict and say like this condition is not really okay, it's just a bit okay. So this kind of small variation, it still does exist.
Well, museum objects, like conservators always say that you have a chair, it has 3 legs. Is it in a good condition or not? It is in a very good condition when nothing else is wrong with it. It's just missing a leg. It doesn't make it worse.
Okay, so but the sort of judging from your explanation, we would really benefit from a good database, an ontology of damages to museum objects. Is there something machine readable being developed somewhere around the world that you've discovered already?
Well, basically, even the status we have now, they can be used, but they can't be used like immediately because we need this more and more text analytics, and the more and more text analytics we get on top of it, and the text modeling, the more data we can actually extract of it. Obviously, it would be easier for machines if we would have just like all these things that can happen are like distributed into various categories and evaluated in like this damage or the status worsening in scale of 1 to 100, 0 to 100, etc. But we can't like move to this. Humans will never be machines, but we can try to organize our knowledge in a systematic and organized way. But
out of your work that you're doing here now, would there be something that you could share? Let's say the damage types or the predictive models that other museums, perhaps in other countries, could be reusing
We have very good part of this project is that there is a very good, or several reports actually written in a very much human readable way, that because even I can understand it. And the one problem with this is that right now it's in Estonian, but it's all in our webpage, and I think we need to also translate it at some point.
Yeah, so all that's left is to invest into machine translation tools that can understand museum speak. You mentioned from the earlier in your presentation, you talked about some projects that were never started because there were problems with data quality.
We started them.
You started and then realized that there were issues. Okay, but there were gaps in data. Was there anything else that you noticed, or what problems with data were there? Can you be a bit more specific?
Well, when you have a project, you always have different, very specific questions. Even like with Sälli, Sälli asks very specific questions, and the available data that can answer these questions. And this is usually, like Jane also said before, that 10,000 books is not enough. So we also have this problem that these 3.7 million objects, firstly, they are very different objects. They can be photographs, they can be different kinds of, just everyday items or whatever things, art and so on. And they have been described in very different ways. Humans are creative, like has been mentioned before. So the available data that can answer the specific questions is always too low. And there are problems also with accuracy of this data. So people have made mistakes just inserting data. There are a lot of duplicates, like whatever you can imagine, and you go into the database of 3.7 million objects.
Entered by so many different people. I guess the problem more is the number of people who've been entering this data into the system.
I would not want call people problems, but
the people are solutions. It might be that the time has changed when this information was inserted, because like the priorities also like in studying these old objects vary across time, and different features and different parameters are set into more focus across different times.
Yeah, we had a paper earlier that discussed this intergenerational continuity of concepts and values. Okay, a little bit also about the background. You said that ordinary museum workers don't do the tech speak. So how is your collaboration going here? How is the division of roles? So what is required of a museum or a museum agency to start an AI project? Well, is it difficult? Can anybody?
I think anybody, yes. If I can, anybody can. but I mean, firstly, you have to have a problem in your hand, and you have to recognize that there might be help in technology. And we, as a small team, have been used to outsourcing very different projects. So it's kind of there is actually a very good, I think, network among memory institutions in Estonia, which you can always ask help from, or even the economy ministry that is very interested in people starting these projects. And we have also done some deep dives with museums, because we work with this MuIS system, but there are many other ways which you can use AI, and you just need a problem in your hand, a will to do it, and also an understanding that it can fail, so a will to experiment as well. Yeah.
That's a very good start. And from your point of view, are museums, or let's say memory institutions, cultural heritage, is that an interesting and challenging use case or application area, or is it sort of run-of-the-mill for this type of technology?
Well, it kind of feels like they're really fascinating, because you kind of try to use the future to make better the past. And those are like philosophy behind it is like really fascinating. And the memory institutions are kind of like really good partners for us because they also want to organize the data. They have like always wanted to organize the data, starting from like the library from Alexandria. Even there, they just try to organize data, which is kind of like the best kind of customers for us.
That's very true. Yeah.
Yes.
So.
Okay, we're in the business of sorting out the world. Thank you for your presentation.